All right, how's it going? Any questions? You have a question. What's your question?
Who is a Cygwin?
Who is a what?
Who is a Cygwin?
Who is a Cygwin?
What is a Cygwin?
What is Cygwin?
What is Cygwin? Okay. So Cygwin is a program you can run under Windows that looks like a Unix environment. Okay. If you're working on a Linux system, you don't have to worry about Cygwin. If you're just working in Windows, you don't have to worry about Cygwin. If you're living in a Windows environment and you want to be able to do things like GCC, awk, sed, grep, Zenity, right? All these Unix things, you can download this program called Cygwin. It's a big program, takes forever to download, but once you've got it on your system, you just run it. It's just a plain old Windows program, and it gives you a nice window that looks like a PuTTY window, right? And it's got a prompt, and you can type in Unix commands, and it does Unix things. And it's a pretty full-fledged implementation of Unix, but it's different from dual booting. It's not replacing Windows, right? It's really just a program that looks like, it's a Unix window. And so if you're doing PA5 and you have a Windows machine, right, one option to be able to run Zenity is to download Cygwin and then work in there as a Unix environment, and you can run Zenity and all this other stuff.
Follow-up question.
Mm-hmm.
Is there a reason we don't have Zenity on the Linux server?
It is on there, but you can't usually get your output from Zenity back to your actual laptop unless you start messing around with X servers. But I'm pretty sure that you can run it from here. It's just that I don't have a pathway to get back to my display. Right. If I do this at home, it'll actually work, but I can't get through Clark's firewall.
Or can you?
Well, not that I'm going to admit on camera. Yeah. If you're on a Windows system and you want to run Linux, right, your other option is to dual boot, which takes up some disk space on your hard drive. Another option is to run VirtualBox. VirtualBox is another program that you run under Windows, but it looks like a virtual x86 machine, and you can install Linux on it. You can install anything that you could install on a regular PC on this virtual PC that's sitting inside your Windows system. And that's a very faithful way to create a Unix environment, or if you want to explore something else, right, it's a virtualized PC, basically a virtualized x86 with virtual peripherals and all sorts of stuff, but it works and plays well with your physical hardware, so you can make network connections and it'll use your physical network connection and so on and so forth. And virtualization is fun. Yeah?
Does PA5 need a rubric, or is it just straightforward?
A grading rubric?
Yeah.
Do everything it says, you get 100%. Yeah. And if you go above and beyond, right, that's bonus karma points, right? You don't get above 100%, but letters of rec and things like that. It's like, and on PA5 this person did blah blah blah, So it's a good chance to sort of stretch yourself and experiment and have fun. But yeah, basically as long as your program runs, gets all that information from the user, updates the reservation file, and gets rid of pre-existing reservations, that's good for 100%. And put comments in it. Yeah.
Are you going to be here on Wednesday at all?
No. Wednesday I am going to be all over the place, including Frozen 2. So, but I will have office hours tomorrow, 7 to 9:30. And I actually have a committee meeting I need to go to at 3 o'clock. So I may be around either slightly before or sometime after, like 4 or 5, if there's something that we need to talk about. All right. Yes. Go for it.
If other members in your group are using Cygwin and you're using a
for Zenity to be a specific directory.
Right.
But when they choose to use Zenity as default in Linux, if they want to reference Zenity, like, can you just use the default of whatever Linux gives you?
Yeah, so on the README, right, there's this thing, if you're using Zenity under Cygwin, it's kind of weird, you have to say /bin/Zenity /bin/Zenity -- whatever, right? So you gotta have all that funny stuff in there. If you're on a regular Linux system, you can just say Zenity, right, and it works fine. So I could say /user /bin/Zenity. Okay, here's something you can do. You always have a variable called $user,
Right.
right? So you could use that to set up an alias inside your
But we
script.
reference so we did that, but if we reference if user is like you or
Mhm.
if it's somebody in our group, and then it says else if it'd be our default would be just whatever Linux local system.
Yeah, like /user /bin/Zenity.
Oh, okay. Linux slash. Okay.
Right, or you could do something like z = which Zenity.
Which Zenity, but then would you reference Zenity with a $sign?
Yeah.
Okay, because when I do that, Zenity doesn't work when I reference it with a $sign. That's the problem.
Go ahead and echo $Zenity and make sure it's pointing to where it actually is. Okay. So yeah, just to finish the thought for everybody else. So you could write an if statement, right? If $user equals Nick, then z equals user bin Zenity. Else if $user equals Arte, right? Then z equals wherever it is on this other person's system, right? And so if you have multiple people with different locations for Zenity on their systems, you can still have the same code, just put this stuff in the beginning to set up a symbol like $Zen to point to the actual version of Zenity you want to run on that system. And then everywhere, instead of saying Zenity, say $Zen or $Z -- entry. All right, other questions?
Question.
Yeah.
So where do we get Cygwin?
So there's a README on Canvas that, so for Cygwin or for Linux?
Cygwin.
For Cygwin, so there's a thing on Canvas for how to install Zenity for Cygwin, and there's a link to the actual executable you can download from there.
Okay.
And then run the executable, go through the standard installation instructions, and then it tells you to copy the Zenity dir that you created into a subdir of /bin/Zenity. And there's instructions there. And they apparently work. All right, did everybody turn in their SLP upload? If you did not, you've got 45 minutes left.
What happens after that?
The iron wall slams down.
I'm really worried that my SLP, what I turned in was like not specific enough.
Yeah, me too.
But like you said, you wanted it to be high level and like kind of simple, but like I'm just worried that it's like not good enough.
So it's a Q1 is an exploration of an idea or multiple ideas for what you want to work on. And your upload is basically a summary of what you found in your exploration, right? And you could have an upload that says, I started off on a project I had no interest in and I changed my mind 2 weeks ago and, haven't had a lot of chance to do anything yet. So you're you'd phrase it more tactically than that. Course correction in the experience of blah blah blah, but no, basically just what's the problem area that you're working on, research, even if you discover that this is not what I want to do, or this is way harder than I thought, it's way simpler than I thought, right? That all goes under your research, right? You can talk about all that stuff. Resources are resources, you know. So yeah, I mean, it's not going to be a finished product by any stretch of the imagination. It's really just kind of a one-pager that sort of says, where am I at right now? You know, we're like 9 weeks in. What's the current status of this? And it's not really assessed on, you know, I didn't make any progress, you know, this is terrible. It's really just kind of, you know, it's as much for you as anybody else to sort of like say, okay, here's where I am, and then you use that to help figure out for winter quarter, okay, what's my new plan of attack, what are my new milestones, that kind of stuff. So, should be good. Yeah.
If we find out that what we turned in wasn't specific enough or didn't elaborate enough, can we have a second chance to?
Yeah, so I'll give you some feedback, and you know, if it's like, you know, relatively minor, then that's that. But if it's like, you know, you didn't turn in anything like what you were supposed to or something like that, I might say something like, you know, go ahead and resubmit this.
This sucks.
But at 12, I'm basically going to download all the ones that were submitted from Canvas, and then I'll bundle those up and send them off to the printer to make the posters. So that's what really happens at 11:55 is you potentially miss the window where I'm going to download them and have them printed for you. So after that, you would need to print it yourself if you wanted to have a poster. So that's the main thing.
Or just have a really bad poster and white out it.
Yeah, yeah.
If we're
Crayons, whatever.
If we're working with like partners in other classes, obviously our forms are going to look different.
So I only really need one upload per group, and if you multiple people upload, that's fine. But I'm only going to print one per group.
Okay.
But hopefully everybody's name is listed under, you know, team partners, so that everybody gets credit.
So one of my partners is in his odds class.
Okay.
It's way better.
Okay.
So I might just use his.
Okay. Did you upload already?
Yeah.
Okay. I'll probably print yours anyway if it's totally different, and then you can compare and choose.
Okay.
So that's fine.
Were we supposed to add pictures?
You didn't put pictures? It's totally up to you. If there's a way where pictures like make it easier for somebody to look at it and read it, you know, that's fine. But you don't have to like, oh, I gotta find a picture. What am I gonna put in here? I'll just put in, you know, some icon I found. No, totally up to you.
Yeah, did you put a video of your
Yeah.
project on it?
Holographic image, you know.
You're supposed to have a screen set up and the entire thing.
Yeah.
Yeah.
That's part of the exercise of this whole SLP, including the presentation, is, you know, get some ideas. If everybody comes over and they look at your poster and they start talking to you and they have no idea what's going on from reading your poster, right? Or they're thinking something different, right? Well, that tells you something about how to present this in the future. So it's all, you know, it's all good learning experience.
Is it okay to dismiss ourselves to go get this uploaded?
Dude, it's college, just leave.
There's no attendance. There was attendance.
Can you do it right after class?
Uh,
Because the Iron Gate doesn't actually come down at 11:55.
Do you want to use my service?
well, yeah, the issue is I don't have a means to upload it right away.
So when can you upload it?
Well, it'd be like in about an hour.
Okay, everybody else close your ears. Yeah, that's fine, you can do it in an hour. Okay.
Dude, let's redo ours.
I'll have to extend the date on Canvas. If I forget, just let me know, but I'll do that right after class.
Just checking, it's totally cool though. A lot of mine was, oh, well, I need to research this and whatnot still.
Yeah.
I was supposed to research this quarter, but my schedule is intense this quarter and later isn't, sort of thing.
Yeah, that's good. That's good experience. The takeaway from that is you know, something for when you're making milestones next time, right? Now you know you might have a really intense schedule of other stuff, right? So factor that in differently, that kind of thing. Yeah, that's cool.
So about the format of the actual presentation itself, if your project is just, say, a thing on a computer, can you use a very computer, or do you want like a big poster board with like whatever? I'm sorry.
It's totally up to you. If you have stuff that you can show on a computer, right, on a laptop or something, bring in a system and you can set it up, plug it in, and use that. If you want to make a sort of traditional poster, right, you can do that. If you want to just kind of have the poster on your display and talk about it, that's fine. If you want to do a mime or a puppet show or something, you know, whatever works. Yeah.
So when it comes to the actual presentation on December 3rd, in a week, I'm going to be half an hour late because I'm running an event at WSU.
Okay.
So is it okay if my partner like is here for the first half
Yeah,
hour
yeah.
and then I come in? Okay.
So there'll be a sign-in sheet. At the front desk, there'll be piles of posters. There'll be yellow extra credit sheets that you can use that we'll talk about later. And there'll be a sign-in sheet. Most important thing, grade-wise, is make sure you sign in.
Okay.
Right? And if you get there late, it should still be there. I try to get around and see everybody's presentation, but I don't always make it. Depends how crowded it is and how slow it is to go from one to another. So only way to be sure you get credit is make sure you sign in on that sheet.
Are we going to be collecting signatures from other people?
Yeah, so let's talk about the yellow signature sheet. So there'll be a stack of yellow pages. You can take one of those. It's got like 25 lines on the front that you can use to get signatures from other groups. So here's the deal. When you are at a quiet point and you feel like, you know, stretching your legs and walking around and looking at other people's projects, you take your yellow sheet with you, you walk over to somebody's table and you read their poster and you say, tell me about your project, and they talk to you about their project and you ask questions and so on, and when you're done you say, can you sign my sheet for me, and they'll sign and put their project name, and that's a signature. Okay, if you get 25 signatures you get 10 bonus points on the SLP.
Nice.
Okay, here's the important thing. I'll get to you in a sec. Here's the important thing. This is not the goal of the presentation. Last year, for the first time, some sort of groupthink emerged. And it went from doing SLP presentations to getting signatures. And it was fascinating. It was beautiful self-organization. Some kind of collective consciousness emerged. And people were like walking around with stacks of signature sheets, meeting each other and just swapping them and signing. And in 20 minutes, everybody had their full 25, and people started leaving.
Free signatures
Okay.
to our board if you sign our.
Yeah. So that's not the goal. So the rule I'm setting up is, even if you see other people doing this, right, I do not want you to walk around and tell people about your project, okay? If people want to hear about your project and get a signature, they have to come to your table and talk to you, okay? They can't just bump into you in the middle and say, so what are you working on? I'm making a game. Oh, cool, me too. Sign, we're done, right?
Can we get these sheets early?
Yeah. All right. Question?
Okay, so I'm solo on mine, so like, can I just leave my spot and go get signatures? Like
Yeah.
people?
So you know, things kind of come in waves. In the beginning, there's usually a bunch of people around because they've been seeing people set up and stuff like that. But when it feels like it's kind of calmed down a little bit, yeah, just throw a piece of paper on, say, you know, back at 3:30 or something like that, and walk around. And if you see like big crowds gathering around your table, you can go back and stuff like that.
I don't know if it would be more or less effective to, instead of you getting other people's signatures based on their project. I mean, sure, you're expanding your knowledge on like what other students are doing, but wouldn't it be like you have a sign-in sheet on your presentation and you have people come up and sign your project as they watch you?
That's a dual way to do it, yeah.
Okay.
And I don't know why we're doing it the first way instead. I haven't really thought about how those two compare.
It's okay, we can
Right,
forget that.
that way you know like students are actually coming to your project and yeah, cool.
Yeah. But yeah, we'll do it the first way. But that's a valid point. Yeah.
Can we record a video of us talking about our presentation, put it on, and then just leave?
Like a Max Headroom kind of thing?
Hold on.
Like a Max Headroom kind of thing?
Sure, yeah.
No. But you can augment your display with a video
Okay.
a
You could sit there while the video plays.
yeah, in a 1960 CRT case, that would be cool.
You sit behind your presentation board, just.
Yeah.
Letting the video play over and over and over.
Now, if you can make a video that's responsive to people's questions, that starts to get more interesting.
That's your SLP right there.
I'll just make an AI bot
Yeah,
to talk to them.
exactly.
Not even my SLP.
Yeah. Well, then
That's
you can
pretty
send it to
cool.
class too,
Yeah.
And it can like take notes and ask questions.
I'll just bring up like, what is it, Cleverbot?
Yeah.
That's a pretty cool SLP.
Yeah, that would
If you
be,
were to get people to like respond to the
definitely.
computer to respond to the questions.
Yeah. I had a friend who applied for a CS program at Berkeley a number of years ago, and she was new to programming, so she actually wrote an interview program and sent them the code for that, and they could ask her questions through the program, and it would come up with responses, and she like coded enough of herself to respond.
That's
to,
crazy, man.
Yeah, she got into the program, so good. All right, anything else?
Wait, so was the program just like a ton of parsing?
Yeah,
Was it actually
basically.
like wow,
Yeah.
that's kind of neat.
Yeah, I thought it was really cool too. But it was probably not something they expected to see. It's like when someone sends in a resume and it rhymes and it's actually a poem. It's like, it's a good attention getter.
I feel
Yeah.
like I would be intimidated.
To hire or not to hire.
Did you see the video of the guy that was submitting resumes as Nintendo characters?
Oh, cool.
And there were a bunch of like auto responses, so he got a bunch of interviews.
Oh, cool. Excellent.
There was one that, the Animal Crossing one, and there was one for Luigi's Mansion.
I've seen people like apply to Wizards of the Coast with like a Dungeons and Dragons character sheet.
Oh man.
Yeah.
All right. So this is good because SLP questions are good to ask a week before. No, I mean that seriously. I normally get these questions like the morning of the presentation. Like, is there something I'm supposed to go to today? It's like, yeah.
Make sure to email him on Thanksgiving.
Yeah. So this is good to bring these up today. All right. So Friday we were talking about processes, and we were looking at process creation and manipulation from Bash. And I said we're going to start talking about how to do this from programming, and we probably got further in the earlier section that we're going to get today, so you can go back and pick some of that up if you want. But first thing I want to look at is a function called system. This is a function we can call from C, and it takes a command, a string. And so I forget what it gets included. Standard lib. So I want to put in the full path to date, and I don't know where it is, so I'm using one of my VI tricks, read from the output of a command, and the command I'm asking for is which date. That should tell me where date's located, and then I'll just join that. So there's a one-line test program. I just call system with an argument of /bin/date. And if I run that, it shows me the date. Okay, not too surprising. I'm just going to leave my typos in here. But I do need printf. All right, so I just threw in a header before and after the call to system. So it prints out about the call system. It calls system and generates that output, and then it says done calling system. So system will let us execute Unix commands. And when it's done executing that, it comes back to our program and continues whatever our C code says it should do. Yeah.
What if you use system on a machine that is not a Linux machine?
It would do something different.
Oh.
It may not even be implemented on other systems. Like if you do this on Cygwin, it'll still work because you're in a Cygwin environment.
Yeah.
But if you are running, I don't know, like Visual C++, and you try to call system, I don't know what it does. I'm guessing it would execute a DOS command, but I'm not sure.
Or would it just be like command not found?
Maybe. Have you done this?
System, no.
Okay.
A system outputs to the screen, does system have a return value?
Probably. So let's print out the return value from system. So the return value there is 0. Now let's try a command which doesn't exist. Alright, so the return call is non-zero.
What just happened?
And if you divide by 256, you get an error code which is 127, which I think is telling us command doesn't exist. If I try to execute bin cat, which will show the contents of a file, and I do that on a non-existent file, I get a different error code. I get a 256, which if I divide by 256 gives me 1. Okay, so that's the actual error code of the program that I tried to run. And the lower 8 bits are an error code from system itself, I believe. Probably says that in the manual pages. Return value. If the command is null, non-zero value if shell is available, or 0 if no shell is available. If the child process could not be created, the return value is -1.
Interesting. Okay.
But 0 is good. So I can execute a system command that includes things like output file redirection. So echo hello, send that out to new file.224. Return with a code of 0. There's our new file .224, and it's got hello in it.
What happens if you use system to GCC system?
That should work.
That'd be crazy, dude.
Oh.
So that works fine, but if this program was big enough, that can get you into some weird space.
Yeah.
Right? Now when this program is executing, it's probably pulled in the entire executable program into memory already. And the fact that it's executing from memory lets me overwrite this. Here's a better one maybe. Alright, so that works fine, but it doesn't work a second time. So you put in the wrong password, you can just delete the program.
That's kind of cool.
Yeah,
It's like a self-destruct button.
totally. And you can use the smoke option to send smoke through the USB port, so it's not installed on the system. Never mind. No, I'm kidding. All right, so system is useful for like a quick go-to. Okay. If you just want to run some system level command, and you can do all sorts of things.
System continually running that program.
So I can execute the ls command, I can pipe that into word count, which gives me number of lines, words, and characters. I can pipe that into awk, which says print the first field, which will just give me the number of lines, which should tell me how many files I have on my system. And then continue with this. But this will do something a little unexpected. So it said 96, and then it said number of files, and then it said done calling system. And this is something we've bumped into occasionally before. Remember, when you do something like printf, blah basically goes into this output pipe. And at some point, we've got our display. That's my CRT. And what's in here comes out on here, and we see the word blah. But this output doesn't happen immediately. Just because you say print doesn't mean that blah is going to appear on your screen. Right? When you say print blah, it really goes into this holding area. And eventually what's in that holding area gets sent to your screen. So when does that happen? Well, it happens if you print out a new line. So if I just change this code a little bit and I put a new line after number of files, everything works as we expect. It says number of files, and then it makes the call to system, which prints out 96, and then it says done calling the system. But without this new line, number of files got loaded up into this output area, not displayed, and then we called system, and system goes ahead and displays the number of files, 96. And then we say done calling system gets pushed into the loading area, and then when we hit that new line, it flushes everything that got saved for output. And so now it outputs everything. So the other way that we can do this is we can use a function called fflush. So fflush is used to force what you've loaded up into this holding area out to the actual output device. And it takes an argument, typically standard out. So after I print out number of files, I could say flush standard out. And now it works the way you expect. So this is why sometimes you're debugging code with print statements, always put a new line after your print statement. Because if you say print, I'm about to execute this function, and then you say print, I'm done with the function, you won't actually see that output until a new line gets executed. So it may be dying in your function, you didn't see the message saying I'm about to execute the function, and you're thinking, well, it died somewhere before that print. Right? So you throw a new line on the end, or you do an fflush call. All right, and I heard somebody say back there, right, we could execute go using the system command. This is not a good thing to do. Okay, if I do this, what's going to happen? Well, this program will exit, but will create a new instance of itself, which will go ahead and start executing. Right. Now here's something I can do. Let's just throw in a sleep here. So we'll sleep for 3 seconds, and then we'll go ahead and we'll execute the go instruction. And then we'll say done calling. That's okay. All right. There's a small chance I'm going to crash my machine here. So let's run this in the background. Oh, interesting. It's called system. right, so there's my system process out there running. I have 2 system processes running. I have 3 system processes running. Right. And if I kill one of them, that should shut everything down. If I didn't have that sleep in there, I'm doing a denial of service attack on myself. Right? And even worse one would be just call that program inside a while loop. Right? And that'll really quickly just like...
Can you show us?
No. I did that once a few years ago, and my laptop actually like failed after that. Pretty sure it was coincidental. I knew it would crash it, but it didn't boot up very well afterwards. I ended up getting a new laptop out of the deal, so maybe I'll show you for Christmas. All right, so system is handy, but it's pretty limited, right? We cannot send input to a program that we're running with system, and we cannot read the output from a command. The output goes to standard out. We could greater than it into a file and then open the file and read it. But it's really just kind of like go off and do this thing, and it kind of does its thing on its own. We don't really get to interact with it very much.
What units does sleep use?
Seconds.
Those are seconds?
Yeah. And I think you need uni. Okay, so I tried to get a manual page on sleep. Well, sleep is also a system command. System commands are in chapter 1. So it checks chapter 1 for a sleep command, it finds it, it tells me about sleep. I want to know about this callable function called sleep. Callable functions are in chapter 2 and 3. So I could try man2 sleep, it's not in there, but then I can try man3 sleep, and that'll actually show me the callable function. 2 is like low-level system functions, 3 is user-level functions. So sleep would be chapter 3. And so I need uni standard in there, but yeah, it's unsigned seconds.
We had the sleep function this whole time, but you made us count over and over
Yeah.
again in assembly.
Yep. Yeah, I know.
Yeah, we don't get to use string copy on most of our stuff either.
Yeah, you can use string copy.
Well, that made 121 so bad.
Oh, really?
121 we didn't get to use string copy.
Oh, really?
That was pretty much all the assignments.
Oh, wow, okay.
Yeah, or string length.
Or string length, yeah. That's a good thing about 224.
So if this only takes integers, how would you do like half seconds?
There's other versions of sleep that are available. So see also nano sleep.
Whoa.
Yeah. So nano sleep. Yeah, it takes more stuff, but with nanosecond precision, we'll highlight it because this is a marketing class after all. There we go. So that gets you more nuanced. And like on a Arduino, there's like a millisecond sleep function you can use, and I think there's a micro sleep also. So. All right, so system is a good first go-to for processes, but the real power is in this function call called fork, and that's a chapter 2 function. And fork is used to create a child process. So here's the deal: you have a main program. Let's say it's written in C, so it's doing a bunch of things. So it does step 1, 2, 3, 4, 5, and then it says fork, and then it does step 6, 7, 8, and so on. Okay, when you call fork, here's what happens. The system creates a new process. New process ID, its own memory space, completely new process. And it's an almost exact copy of your current process. So after the call to fork, that new process is going to go ahead and execute steps 6 and 7 and 8 just like the original process. Okay, it's a clone. So we can play around with this. And I will say hi, we'll call fork, and we'll say hi again. So what just happened? We ran our program, it said hi. We called fork. Fork created a second copy of the program that thinks it just called fork, and then goes on to the next set of code which says print out hi again. So we got hi again printed from two processes.
What if you print out a random number?
It'll be different if you seed it differently, but the random numbers on Unix are not random. They come from a random looking sequence that you have to give an initial value to. But we'll do something almost as good as that.
It probably doesn't matter because it's an exact copy, but which one is first?
Yeah, good question.
Whoa.
So let's print the numbers from 1 to 100 side by side.
Doesn't the percent need a bookport?
Oh. Glad I'm not the only one hearing that.
Is that physics?
Yes. Yo, how do you get it to not do that?
Just don't do that.
Okay. I did it by accident, and I was just
I did a colon Q exclamation mark, and that seems to get you out of it.
Okay.
All right, so let's run this. So it says hi, and one of them prints out 0 through 99, the other one prints out 0 through 99. Not too startling there. Let's go from 0 through 5,000.
Okay.
Okay, so let's look at this.
Oh, God. I can't read that.
All right, so started printing from 0, got up to 100, got up to 280. And then we jumped back to 1 because the other process kicked in
Huh.
and
just kept
started
going.
printing. And the other process got up past 280, got up to 300, 400, 500,
So,
and 38. And then
It went back.
started to
What?
print 539. So
So
we
it's
got
just
a
gonna
3.
Do itself.
What was that 3? That 3 was the end of the 283. Right? So 281, 282, 28. And then the second process kicked in.
I have dyslexia
So the
now.
second process is the fourth process?
Probably. But we'll look at that in a sec.
Okay.
All right, so yeah, this one kicks in, and then the other one came in at the 3 and continued. And so these are interleaved, right? They're you know, one of them starts outputting in the middle of the other one's output. Why? Because the first process runs for a fixed amount of time, and its quanta of time expires,
Right.
and the scheduler throws it out, pulls the next process in, and that starts running.
What would having multiple force statements look like?
Yeah, we'll do that too. All right, so let's look at who goes first.
who's on first?
Yeah, what's on first?
What's on second?
I don't know. Third base. All right, so we'll say hi, we'll call fork, we'll print out the return value from fork. So one of the calls to fork got a return of 22,131, the other got a return value of 0. So I said that fork creates an almost clone, right? So you look in your inner eyelid and you see the little dots that says which clone you are, right? So that's what fork is telling you. The return value from this will be one of two things. If you are the parent, then you get the PID of the child. If you're the child, you get a return of 0 from fork. And that's how you can figure out your identity after you come back from fork. Because you're going to be doing the same code whether you're the child or the process. You're both going to say print out the return value from the fork. So we can do something like this. Right, if the return value from fork was 0, you can say I'm the child, otherwise you can say I'm the parent, and the child PID is, and we'll print out the value of I.
Alright, how do you get it to stop? Like if you wanted to repeat a certain section of code and then just continue on from there.
So you could say if I'm the child, right, if the return from fork was 0, then do such, right, skip this code or run that code or whatever you want to do in particular. But that's the only thing that you have to differentiate yourself is that one return value, and you have to do everything from that.
Okay, so you probably like write another function so that it's cleaner and then branch to that?
Yeah.
So if you do multiple forks, what are the return values then?
So there's a one-line test program, just prints out fork returns and tells us what the value of fork is.
Yep.
What did I do?
It's at the, that's at the end.
Oh, thank you. All right. So, let's just do 4 of those.
Okay.
Bam.
Wow, there's too many parents, man.
Yeah.
Wait, what? What happened?
We made a fork bomb. Don't do this.
What does that mean?
So, the first call to fork creates a pair of processes. It creates a new process, so we have 2 processes. Both of those processes are about to execute that second call to fork. So after that, we have 4 processes. All 4 of those execute the third.
That's
right?
crazy.
So the child becomes a parent.
Child becomes a parent. Yeah.
That child becomes a parent.
Yep.
It's like generations.
Yeah.
If you tried
Sure.
to get a return from one of the child parents, would you get a 0? Or?
Depends if you have a receiver.
If the child creates a new process, it will return the PID of its child, even though it was a child. And pretty much every process on a Unix system is a child, right, except for init, the first process. So if you call fork inside a while loop, like while one fork, that's a denial of service attack. That will, in general, mess up your day.
That's like the basic denial of service.
Yeah.
Which you just taught us in class.
Right? That's all you need in a C program to either wreck a system or get yourself on a list as someone who tried to wreck a system. So on the Linux server, it should be set up to only let you create, I think I set the limit to like 10 processes, after which your program will get a message saying, you know, resources not available. But don't test that, okay? So you can test it on your own system if you don't mind having to reboot. But that'll basically use up all the available process slots. And because it's running in a loop, right, if you try to kill some other process to free up space, it'll grab that space immediately. And if I want to do like a PS to see processes that are out there, well, to create a PS command, I need another process to be created, and I don't have space for that. So it really, really hamstrings your system.
So, if you just like write a program that does that,
Yeah.
the wild fork,
Yeah.
it'll crash your system.
Pretty much,
You
yeah.
reset it, and then you're good.
Yeah.
Can you, in some way, put this code in the bootstrap so that when it boots
Yeah.
up, then it just continues?
Yeah,
to
you
crash?
could.
That's super
How?
gnar.
Just
Google.
pretty easy to do. And the way you fix that is you go and you change the bootstrap code. So you like
How
run
do you
a.
do that without like?
You can run Linux from a flash drive, boot it from a flash drive,
Oh, that's
and then
right.
just mount that drive that contains the boot code.
You can still
But you're more likely to mess things up just by tinkering with the boot sector.
So just do that.
Yeah.
Wow.
So yeah, so don't do that on anybody else's system, but you can experiment with it. The problem is when we start working with forks and trying to write code, sometimes we accidentally do this, and it's a little hard to get out of.
Okay, so if you want to mess around with stuff like that,
Okay.
theoretically, would like buying a ton of Raspberry Pis be a good way to just try to crash stuff?
Yeah, I mean you can just do that on one Raspberry Pi.
Right, but if you want to like really mess it up,
My username.
Yeah, you can't really mess up a Pi too much.
Okay, but what if that's your goal?
Well, so it boots from, you know, a micro SD card, and you just throw a new operating system on there and it boots. Yeah.
That's crazy.
If you really want to use a
That's crazy.
The main thing is, if you try this on your own system, make sure you don't have any open files, you know, don't be halfway through editing PA5 or something and be in the middle of VI. You just want to make sure all the files are closed so that if you have to power cycle to reboot, it doesn't do any harm. All right, so I'll see you tomorrow. We'll talk more about